So in the video that you just watched, you saw what's probably the most common example of what we call a neutralization reaction. It's something you've actually done already in class. If you think back to right around the start of second semester when we did the vinegar and baking soda rockets, we were using this neutralization reaction. So what a neutralization reaction is, it's when we take an acid and we combine it with a base, and because they're opposite sides of our pH scale, when they mix together, they essentially balance each other out, or they make each other become neutral. So if we look at the vinegar and baking soda example that you just watched, vinegar is an acid, baking soda is a base. So when we combine those two together, the H pluses from the acid, from the vinegar, mix with the base part of baking soda. So it's a little bit more complicated because baking soda is NaHCO3, so it's not as simple as just H matching with OH like we've seen in some of our really easy ones. But what ends up happening is those two balance each other out, and we create two things. We create something that's neutral, and then we create a water. So every time you see a neutralization reaction, whether it's the vinegar and baking soda reaction, or it's a little bit easier to understand chemical reaction like the one we're going to look at here in a second, if it's a neutralization, it will produce those two things, a neutral salt and a water. So we've already talked about the vinegar and baking soda reaction and how it's technically this carbon dioxide that makes the reaction do the things that we want it to do, like pop the rockets or explode the volcano, like you saw in the video. So if we look at a simpler neutralization reaction, we can look at this one down here. So these are probably the two most common, most talked about acids and bases that you'll see in all of chemistry. Anytime we talk about an acid or a base, these are probably the first examples people are going to give. So this is hydrochloric acid, HCl. We've used that already in class. And this is NaOH. This is sodium hydroxide. We've also used this one in class. So hopefully by this point in our acids and bases, you can tell which one is your acid and which one is your base. Remember, your acids are the ones that have the H attached to them. Your bases are the ones that have the OHs attached to them. So in this case, HCl is our acid, NaOH is our base. Because we know that neutralization reactions balance each other out or neutralize, we know that when we mix an acid with a base, we're going to get a neutral as a result. So if we look at these two things in this reaction, here's how this works. The H from the HCl is going to come over here, and it's going to steal the OH from the base. That's going to produce HOH. Maybe you've never seen that before. That looks a little weird. Remember, it can also be written like H2O. So there's your water. We know that water has a pH of 7. We talked about that when we talked about the pH scale. It's neutral. So it would make sense that in a neutralization reaction, where an acid and a base are neutralizing each other, that we would create a neutral water. So that uses up this part right here and this part right here. Then we're left with the other part of each of our two reactants. So we have an Na and a Cl. Hopefully that sounds a little bit familiar to you too. When we put those two together, we get NaCl. We've talked about NaCl before. This is salt. This is actually the salt, like table salt, like the stuff that you put on your food. A lot of times we're going to talk about a salt being a type of chemical. So like this is not a salt that you're going to use on your food, but this one actually is. The rest of the salts that we'll talk about, that's just a name for a neutral chemical, a chemical that's not either an acid or a base, but it would have a pH of 7. So in this case, our neutralization reaction here, we've taken an acid, we've combined it with a base, and we've created a neutral salt and a water. That's the same format that every neutralization reaction you're going to look at will follow. They always take an acid plus a base, and they form a salt plus water. So this right here would be an important thing to put in your notes on acids and bases. Remember, we call this a neutralization reaction. And we said it makes sense, a neutralization reaction, because salts are neutral and water is neutral. That neutral pH is 7. In order to get these neutral things, we have to combine something that has a pH of less than 7 with something that has a pH of more than 7.